Here's a tutorial on how to make a simple autonomous. Before we get into the code, I want to just explain a little bit about autonomous. So the autonomous period is the first 30 seconds of the robot match where the robot relies on pre-programmed instructions without human control. There are many different types of autonomous, such as time-based autons, encoder-based autons, and roadrunner-based autons. This tutorial is going to be on how to make a simple time-based auton because it's one of the easiest ways to make an auton and it's really beginner friendly if you're just starting to get into the code. So let's get into it. First step in making your auton is to declare your motors. You're not declaring it you're not like finding the hardware map and like reversing the motors right now. You're just saying that, okay, these motors exist, I'm going to use them. I'll go more in depth in that later, but not really important right now. So DC motor, and then whatever the name of your motors are. So for me, it's front left motor, front right motor, back left motor, and back right motor. The next thing we're going to do is declare functions. So what are functions? Functions are basically like a set of instructions that do something specific. You give it an input and it performs a task. Let's make a few functions. So let's say we want to move forward. We can make a function for that. To start off, to make a function, it starts private void, and then whatever the name of your function is. So mine's going to be move forward. And then you put in a parameter. So, for example, double power. Double is like the type. So it's just saying that power could be a decimal. It also could be an integer. If it was only an integer, then I would replace double with int. But since I could be putting power like 0.5, then I need to put a double. And then since it's a function, you have to have the parentheses. And then you want to actually start by, you move forward, you have to set power to your motors. So front left motor dot set power, and then you can copy and paste this for your 4 motors. So front left, front right, back left, and back right. And for positive power, if your power is like 1 or 0.5, that's positive, and therefore the motor spins forward. But if it's a negative, like negative 0.5 or negative 1, then it spins backwards. So if I want to go forward, then all the motors should be a positive power, so therefore they all spin forward, and therefore the robot moves forward. That's one example. And then I'll set in another example. Let's do move back. This one's gonna move backwards. Similarly, if I wanted to go forward, I'd set these to positive power. If I wanted to move back, then I'd set this to a negative power. The negative spins it the other way, so all the motors are gonna move backwards. Alright, and then we'll only do these 2 for now, but I'll just, if you want to turn right or left, it's really similar. The format's the same for a lot. You just have to change what's inside here to either a negative power or positive power. But other than that, it's basically just setting power to all 4 motors. If I wanted to turn right, then the the left motor should spin negative, and the left motor should spin positive, and the right motor. Oh yeah. So the front left and the back left should be spinning positive, and the front right and the back right should be spinning negative. So basically, the front right and the back right are spinning backwards. The front left and the back left are spinning forwards. So therefore, it turns right. And then it's really similar for turning left. Except instead of this being the power, it'd be positive, positive, negative, negative. So in this case, front left and back left are spinning backwards. Front right and back right are spinning forwards, so it turns left. So these are obviously just the basic ones, going forward, backward, turning right and left. You could do strafing, strafe right and left. That's a big one too. So there's a lot more functions you can do, but these are just basic ones, and yeah. Okay, after this is where our code starts. So you've had your override term, and then public void run op mode. This is your main function, obviously. This is where you actually run your code in. And then you need your hardware map now. So this is where you actually are finding your motors from your configuration. So run. And always end every line in a semicolon. And since I was calling these names in my functions, I had to set it up over here. If I didn't have this line, then it wouldn't recognize this because I was setting it down here. Since this is after these lines, then it wouldn't know to use it. But I just had to say these are my phone motors, and then I go down here and then actually call it from my configuration. And then you have to set your direction of the motors. I'd like to note that it's easier that if you copy and paste these lines, these hardware map lines and the direction lines from your teleop, because they're the same format, and it just saves time. So you wouldn't have to like write it out like I am right now, but. And then back, right, motor. Okay, that should cover it. And then after that is where you actually start running your code. So wait for start. And this just tells the robot to wait until the match actually starts, and then if this is saying, okay, when I press start on my driver hub, the code inside this loop should run. So right now is where you actually call your function. So let's say I want to move forward. I'd have to write the function name, which is move forward. And I'd also have to give it a parameter. For example, if I have to put in a number in this parentheses. The number I'm giving is called power, and that power is used down here. So if I put in 0.5, it says front left motor set power 0.5, front right motor set power to 0.5, back left power set to 0.5, and back right power set to 0.5. So whatever you put in here, it's basically storing it in a variable, and then it puts it down in here, 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 and here. And the same thing over here. If I put in 1, then it sets the power -1, -1, -1, and -1. So, yeah. I'm just going to set it to 0.5 for now, because that's the speed I want to go at. Not too fast, not too slow. So this is just setting the power. But how do I actually make this go forward or do whatever the function is saying? For that, you need to call a sleep function. So this line is basically saying to move forward at a speed of 0.5 for 1,000 milliseconds. So this is the amount of time it moves for. So if you put this at a higher number, then it moves forward more. If you put it at a lower number, it moves forward less. And it's in milliseconds. So 1,000 milliseconds is 1 second. So this would just move forward for 1 second. And if I just change it to 2,000, it'd move forward for 2 seconds. That's one. For every function, you have to give a sleep for how long it goes. Otherwise, it's just not gonna do this. So if I didn't have this, if I just didn't have that, then it wouldn't do anything. This actually tells it for how long to go for. So right now my code's going it's gonna move forward for 2 seconds. Let's turn right. For let's put it at a speed of 1, and then make it turn right for 500 milliseconds or 0.5 seconds. So obviously you can make a whole code out of this. You can have it move forward, turn, go in any way, And as you see, this is really basic, but still you can do so much with it, and it's still really helpful if you just want to learn. And there's so much you can do with this. The possibilities are probably endless. But yeah, that's it. Thank you for listening.